Assalamualaikum and hi to everyone. Today we will discuss on chapter 8, which is the 8088 and 8086 microprocessors, their memory interface, and our group will be discussed on 8.12, which is memory interface circuit. So our group members consist of two. The first one is Nur Hayatunisa binti Andrie, and second Nur Hakimah binti Muhammad Zulfaqar. The table of content of our discussion consists of 5. The first one is we will discuss on the overview. Next, we will discuss on memory interface block diagram. Third, we are going to discuss about address latch. Fourth, we are going to discuss about bank write control logic. And the last one, we are going to discuss about bank read control logic.
Overview. So, in this subtopic, we will show you how the circuit and memory interface work with each other, starting from the X0, X6 MPU, X2, X8 bus controller, the address latch, buffer, and the address decoder, and the bank control logic, where the address will be latch, buffer, and decode to select the upper, lower, or both banks of the memory array until they come inside the memory subsystem. So, we will also study more on how to set the appropriate banks of the memory array for write and read the data. So basically, in this subtopic, we are going to talk about what kind of chip and circuit that flow and connect to the memory subsystem to form a good connection so that the memory can perform better. When we talk about memory, it will talk about how we can store a data, or in this context, the memory array, so that we have access to either to read the data or write the data from memory. The data will be saved inside a different bank control that already embedded for each function. We will discuss about the bank logic control later on.
Okay, as you can see, this is the memory interface block diagram, which is building blocks of the maximum mode 8086 memory interface. All of this diagram consists of 8086 MPU, 8288 bus controller, address bus latch, bus transceiver or buffer, and bank control logic, which consists of bank write control logic and bank read control logic. This is the memory subsystem. And now I will be explaining a little bit about this diagram. The bus status code here for type memory access output to 8288 on S2 bar until S0 bar. Then 8288 decodes to produce the command and control signals need to coordinate the data transfer. Here. Then address is slash, buffered and decoded to produce chip enable signals for the memory array. Select a specific memory location. Select upper, lower, or both banks of the memory array. Now we move to MWTC here. MRDC. I will be explaining what is meant by MWTC and MRDC in the next slide. So MWTC bar and MRDC bar combine with AOL here and BHEL to set the appropriate banks for the memory array to write or read respectively. Yeah. Then we move to DT or R bar, which means data transfer or receive bar. Here, this is data enable, are used to enable the data bus transceiver or buffer and set it for the transmit, write, or receive, read direction. So before we move to the next subtopic, here are the meaning of the vocabulary the slide before, which are MRDC is memory read and WTC is memory write.
This is how address latch circuit looks like. The latch were implemented with 374F373 octal D-type latch. So address latch will buffer the signal so that they may be used to divide a large memory system into a segment. So address 0 until address 19 and BHE, that is bank high enable, is latch address signals. If the OC here equals to 0, so it will become enabled permanently in the latch. Next, we will go into the inputs of the address latch. The inputs here like address data 0 until address data 15, address 16 until address 19, and BHE here come from X0, X6 MPU. And next, the address latch enable or LLE came from X to X bus controller, where all latch clock we in parallel with bus at LLE. Okay. Then the latch will produce the output A0L until A19L and also BHEL bar, where for each latch it has 8-bit address. Like this, the first latch has address 0L until address 7L. The second latch address 8L, address 8L until address 15L, and the third latch have address 16L until address 19L, and also BHL. All this output address from the latch output will be applied into the address inputs of memory subsystem, address decoder, and also for bank read and write control logic. So in here we need to take note at the address A0L here and BHEL bar here, because they will become an input and they will be used for the read and write bank logic control circuit in the next slide.
So we proceed to bank and write control logic circuit. As you can see, this is the diagram. The first one is AOL BHEL bar AOL that come from address latch here, and MWTC bar or MWRC bar that come from 8 to 88 bus controller to produce independent write signals upper and lower. So based on this diagram, it will have two output here, two output, because memory array is organized in upper and lower banks. This is upper and this is lower. So I'll be explaining about this table, but before that, MWTC bar or MWRC bar will be set to 0 because it will enable both gates here and here. The first one, when BHEL bar is 0, AOL is 0, WRU bar is 0, WRL bar is 0, and the result, both banks enable. Okay, next, when BHEL bar is 1, AOL is 0, WRU bar is 1, WRL bar is 0, so the result is lower bank enable. Okay, so the last one is when BHEL bar is set to 0, AOL is 1, WRU bar is 0, and WRL bar is 1. The result is upper bank enable.
Next, I will talk about bank rate control logic. So, bank rate control logic basically similar to bank rate control logic. The difference here is in 8 bus controller they use MRDC or memory rate as the input for the bank rate control logic to produce the read upper and the read lower into the memory subsystem. So, bank rate control logic must decode the address 0L, BHEL bar that come from the address latch and MRDC bar from the 8288 bus controller to produce independent rate signals upper and lower. They will have two output here. Because memory array is organized in upper and lower banks. It states that if memory rate equal to 0, it will enable both gates. And this is the input of the bank rate control, and this is the output that will be produced of the circuit. So to read the truth table of the bank rate control logic, first, if the output of the BHEL is equal to 0 and the A0L equal to 0, so the output of the read upper will become 0 and read lower will become 0. It states here that if the output equal to 0, it means that the bank will be enabled. That's why if BHEL and A0L is equal to 0, both banks will be enabled here. Next, if the BHEL equal to 1 and the address 0L equal to 0, the output of the read upper will become 1 and the read lower will become 0. It means that the lower bank will be enabled here. The lower bank will be enabled because read lower is 0. The third one, if BHEL equal to 0 and the address 0L equal to 1, and it will produce the output of read upper will become 0 and the read lower will become 1, and it will produce the result of upper bank will be enabled. So that is for the bank rate control logic. This is how they read the control logic in this topic.